of you. In this video, I will discuss about the one application of dimension, and that is how to make a formula by the help of dimension. So you see here, make formula by help of dimension. So there are a set of steps involved in this process. So I'm just taking an example. Let's suppose we know better that the formula of velocity is displacement upon time. It means that velocity depends on displacement and time. So first of all, whatever the formula you want to derive, so just check it out that that particular formula depends on how many variables. So this is our first step, that determine the physical variables, that the particular term depends on how many variables. Number 2, assign the power. Step 2 is what? Assign the powers. So like V is depends on displacement and time, so I'm taking a displacement power is A and time power is B. So this is our second step. In first step, you need to write the relation between that particular physical quantity and on how many physical quantity that particular physical quantity depends. So this is our first relation. In second relation, assign the power. This is step number 2. In step number 3, this proportional sign will remove and some constant will come, and that I'm just taking K. So in third step, that will be equals to K d to power A that I have assumed, and time power I have taken B. This is your step number 3. In fourth step, you have to put the dimension of each individual physical quantity. Like V is velocity, so the dimension of velocity is just put here, so you will get Lt minus 1. K is constant. Earlier only I just told you that there is no dimension for the constant, so K, need not to use dimension. D is displacement. Displacement is a kind of length. So what is the dimension for capital D? Means small d, L, and the power is what? A. So just put a power here. And T is time. So for time, use dimension capital T, and power is B. So this is our step number 4, that we have to substitute the respective dimension. Okay. In step number 5, you have to compare the LHS to RHS term. Like here the power of L is what? 1, and the power of time is what? Minus 1. Similarly, in RHS, the power of L is A and the time power is B. So just compare the powers of same quantity. So here the power of L is A and here the power of L is 1. So while comparing, A is what? 1, and here the power of T is B and here the power of T is minus 1. So while comparing, B is what? Minus 1. So your major agenda is ki whatever the variable you are taking, like we have supposed the power A and B, so that you have to find. To just make any formula, whatever the powers you are considering, that power you need to find by this method. Okay. Now when you have value of A and B, then go to step number 3 and put the value of A and B. So V is equals to K, d to power A means 1, and time power is minus 1. Minus 1 will go to denominator, then you will get V is equals to K d upon T. And here K is constant, which value is 1. So you can get the formula V is equals to d upon T. So like that, we can just derive the formula of velocity. That velocity formula is what? Displacement upon time. One more example I'm just taking to just clear your concept. Okay, see here. Let's suppose if our centripetal force depends on mass, velocity and radius. Now you have to find the formula of force in terms of mass, velocity and radius. So how we can just find it? So what is step number 1? Step number 1 is you have to find a physical variable and on how many physical variables is depends. So force depends on 3 variables. This is our step number 1. In second step, you have to assign the power. Okay. So F is depends on mass power, I'm taking A, velocity power I'm just taking B, and the radius power I'm just taking C. So this is your step number 2. In step number 3, just this proportional sign will remove and some constant will be added. So in step number 3, F is equals to constant, I'm just taking K, m to power A, V to power B and R to power C. Now what is our agenda? Our agenda is to find the value of A, B and C, because that we have taken. So whatever the assuming term is there, that you need to find the value. Okay, so in step number 4, you have to substitute the dimension of each individual term. So the dimension of force is what? F is equals to ma. From there you can get the dimension of force Mlt minus 2. For constant there is no dimension. Mass, capital M dimension, and the power is what? A. Similarly, V is velocity. The dimension of velocity is Lt minus 1 and the power is B. R is what? Radius. Radius is a kind of length. So for length we use capital L and the power is what? C. Now this is our step number 4. In step number 5, just separate the term of M, L and T. So here also I have separated like M to power 1, L to power 1, T to power minus 2. In RHS also, here M is coming only one time, here only. So M to power A, L is here, and here also, here L to power B and here L to power C. So whole we can write L to power B plus C, because that all terms are in multiplication. So when multiply, the power will be added. So what we can write here, L to power B and here L to power C, so L to power B plus C. And similarly for T, T to power minus 1, when it will multiply with B, so you will get minus B. Now this is our step number 5. At last step you have to compare the MLT power of LHS to RHS. Okay, so here the power of M is 1 and here the power of M is A. So what we can write, A is equals to 1. Similarly L to power is what? B plus C, and in LHS L to power is 1. So B plus C is equals to 1. This is our equation number, whatever you can substitute like 1. And this is our equation number 2. Similarly T to power minus B and here T to power minus 2. So what we can write? Minus B is equals to minus 2 means B is equals to 2. Now put the value of B is here. So 2 plus C is equals to 1. C is equals to 1 minus 2, that will be equals to minus 1. Now we have a value of A, B and C. So just go to step number 3 and substitute the value of A, B and C. Then what you are getting? F is equals to K is constant, M to power A. A is what? 1 means M1. V to power B. B is what? 2, so MV square. And R to power C. C is what? Minus 1, so minus 1. It will come into denominator, then you will get MV square by R. K is constant. Generally constant K is 1 here. For the constant we take value 1. Then what you are getting? F is equals to MV square upon R. So by this method you can find any formula if you are knowing the particular physical variables, and that particular physical variables depends on how many variables. If you are knowing the variables, then you can get the formula. Okay, same you have to do it for if mass depends on force, velocity and time. This is a homework. If mass depends on force, velocity and time. So what we have observed here, that we were just deriving the formula of F in the term of mass, velocity and radius. So formula we have got mv square upon r. This formula ensures that only when mv square upon r exists, then this is equals to the force. It is not like that mv cube upon r should not equals to the F. That's why we can say the formula, whatever it is making, like for the kinetic energy, half mv square is there. So that mv square only exists, mv cube or mv to power 4 cannot exist. So like that you can just check the validity of particular formula, that particular formula is correct or not. You can just check it for F is equals to ma also. Like if I'm just saying that force depends on mass and acceleration, then find the formula of force. So you will solve by this method, then you will get the same formula, that F is equals to K ma, and the value of K is 1. So similarly you will get F is equals to ma only. This term you will get only, so only this formula can be maintained. It's not like that F cannot be equals to ma square, F does not equals to m upon a, F cannot be equals to m square a. Only F can be equals to the ma. So by which you can check the validity of particular formula. Okay, so this is your homework. Just check it out. Till then, thank you. Like that you can just check the validity of linear momentum, like P is equals to m into V. How this formula can be maintained. So P is proportional to mass and velocity. Then substitute the dimension
and just compare it, then simply we'll get P is equals to MV. And any formula you can check the validity of particular formula by the help of dimension method. So here we have just studied about all three application of dimension. Now in next class we will discuss about the errors. Okay, we will jump to the error topic. Till then just keep the study and just thank you.